And we're starting with another edition of the MLOps community, Coffee Sessions. Today, sadly, I do not have a coffee, but I do have Soumanta, who is going to be talking to us a lot about his learnings from building a bootstrapped MLOps service startup. And if you would like to know what that startup is, I am actually really excited to hear about the origin of this name. It's Yugen.ai, and Soumanta, welcome to the show. What's this name all about?
Yeah, thanks, Vishnu. Thanks, Vishnu. So, Yugen is mostly a concept from Japanese aesthetics. And the funny backstory there is that in India, when you try to register a company, you have to give multiple options saying that these are possible names, and the government has the right to reject a few names if it already exists. So we came up with a bunch of names. Sadly, none of them worked. And then one day we kind of sat down and tried to find out, what is it that's a little uncommon, yet still means something that's related to what we want to do. And I think it was probably 2 or 3 at night, and I was just going through multiple just blogs and all of those things, and then I came across this term from Japanese aesthetics, which essentially means that the universe has a lot of, it's a set of complex problems, but the solutions inherently are beautiful. So it's a deep and profound appreciation of those solutions, and given that we wanted to be in the problem solving industry, especially problem solving using ML, we thought that might be a pretty apt name, and that's how it came to be.
I love the way that you went about that. So could you talk to us a little bit about what you've been up to for the past couple of years? And I know you started Yugen about a little over a year ago, right? Maybe you can walk us through what it was like before, and then why you decided to start right during the pandemic and or a month before the pandemic, right? And then how that turmoil has been and what you've been up to since then.
Yeah, sure. So before Yugen, I kind of spent most of my professional career in the data science consulting world. So I was based out of India for a while. I moved to the Bay Area for a couple of years, and then to Seattle, and then moved back. But most of that was, working with clients across the globe and trying to implement multiple, machine learning solutions to some of the problems that they have. When I moved back to India, I also worked for a product startup for about a year. And during the time that I was doing a lot of ML consulting, that was mostly around, building models. And that was just the extent of it. So typically at the end of it, we would, the end output would typically be maybe like a presentation or certain things in Excel where the model's predictions were being used, and that's the extent of the knowledge or the experience that I had. However, when I started working for a particular product company, that's when I first got introduced to software engineering. I kind of picked up a little bit of backend microservices work and all of those things. So that gave me a little bit of an introduction to software engineering in the first place. And of course, even though I wasn't in the data science services industry at that point in time, but I was still pretty much connected to a lot of folks that I'd worked with in the past. And you kind of see a specific trend that the distance between machine learning or let's say data science and software engineering, that gap was pretty much decreasing, and it was decreasing at a pretty quick rate. So that was the preliminary hypothesis that we had. So around Jan or Feb 2020 is when we kind of my co-founder and I finally took the plunge. March end is when we had our first customer. We've been working with them since then. The first 8 to 9 months was just the two of us. Right now we are a team of 8. Fortunately, we've been able to grow, at least in bits and pieces, even despite the pandemic. And yeah, I think we're mostly working on projects such as personalized rankings, product recommendation, but yeah, the entire full stack ML systems is kind of that's what we've been building.
Incredible to hear. So you started your company right as the pandemic was starting. What was the all-around feel and emotion as you were going into that? And how did you have the determination to continue, even though everything around you was being turned upside down?
Well, in some ways, it. So let's say, for example, the work from home thing. That's something that I started getting accustomed to a couple of months before the pandemic began. So that kind of felt like an extension of what I was currently doing. But yes, I would say one of the most motivating factors was the fact that the learning curve was very steep. So before, like I mentioned, when I was in the ML consulting industry, I had never deployed even one model. I absolutely had no idea what that meant. And here we were in 2020, and we had a client, and we kind of promised them that within 3 months we will find a way to kind of show impact. And that meant, apart from building models, we had to go ahead and deploy that. And what one of them had suggested was that why don't you try and deploy something in a little less than 3 weeks, which at that point in time was extremely challenging. But yes, I remember I used to stay up late learning about. I had a little bit of idea about AWS Lambda and all of those things, but yeah, kind of stayed up late, kind of coding all of that stuff, building those pipelines, the APIs. And then once it started working, and when we first sent that request in production and it was working, I think that was something that at least personally gave me immense amount of satisfaction. And I think since then, that's been a constant that has been applicable, whether it's to me or anyone else in the team. We pretty much focus a lot on impact. And we pretty much every 1 month we get back and see it, what's the scale at which we are serving recommendations. If we've built something, how many individuals are at least using that recommendation. So I think that's been a pretty helpful aspect of being sane. And I think apart from that, of course, I personally started enjoying a lot of alone time to kind of reflect on what's happening, what else can we do. But it took a while, but I think gradually we got used to it.
That's awesome. And so I guess one of the things, we have a lot of MLOps, vendors, instructors, and various industry participants, approach us, as part of being in the community or just being on this podcast. And one of the things I'd love to do is kind of get a sense of what your perspective is on where we are with building ML systems, given your experience and given where you're at with building Yugen. What do you think of the state of the art right now? And what do you think the priority for Yugen and for the industry should be over the next 5 years?
Okay. Well, I would say there would be a little variation across multiple industries, but at least the ones that we've worked on, my 2 cents on that would be, and I would kind of break it down into, or break companies down into, I would say, 3 different segments. So one would be companies who are trying to go from 0 to 1 in their ML journey. Second would be 1 to 10, and then you have big companies, the third segment. I think for 0 to 1, some of the top priorities, or at least some of the top trends that we're seeing or we've seen up until now is extremely fast time to value. So you don't necessarily need to spend a lot of time building your first baseline or first preliminary model. You can get that up and running very quickly. And second is how quickly can you experiment? You won't have the answers right away. For a company that has, let's say, a small product that's, let's say, in one country, and you're going to probably launch in a few countries later on, things will change. The product features will change. So there's going to be a lot of variation. So as long as you're able to experiment quickly, learn, and kind of iterate. I think that's very crucial. For the second segment, where for the distance between 1 to 10, I think that's where, apart from the first two things, the other thing that really comes into perspective or is really important would be a very strong engineering culture, and followed by a proper MLOps process or ML system. And that's where you have a lot of other things coming in, like testing being a very important part, and that's something that we learned the hard way, where we hadn't really focused a lot on that aspect in the beginning, but focusing a lot on tests, on monitoring. At that point in time, of course, your machine learning team would have also scaled a lot. So, how do you have that strong engineering culture and you can still move fast? The third segment, I would say, at least in my professional experience, we haven't worked with a lot of such companies, and that's not our priority right now. We were more focused on, I would say, the first two segments. So I probably may not be the right person to comment on that. But yeah, I think the first two ones are what I'd be more comfortable with.
Yeah, that's a really good breakdown, I think, of how the different companies kind of approach ML and what their relative needs are. A follow-up that I have in hearing you talk about the 0 to 1 in particular, it's your analysis of what's important there, fast time to value, and being able to easily get started. It squares a lot with the future of dev tools generally, right? That's what Stripe and a lot of these other companies that are very dev oriented have done really well. How does building a tool that has fast time to value square with the fact that a lot of those companies are struggling with how to define what ML means to their business to begin with?
Yeah, great question. So taking a step back, I think one of the most important realizations that we've had is that ML at the end of the day is a very important method or a very important way of solving a particular business problem. So you always need to start with what the business problem is, what exactly do you need to achieve, and then chart your journey according to that. I think that's, I would say, the differentiating factor where you keep the exact, let's say, 3 month, 6 month priority in mind, or what that journey is, or what the set of business KPIs are, and then kind of customize your own ML journey according to that.
I want to talk about something that you mentioned beforehand when it came to this idea of building the strong ML engineering culture, and how, like for you, because I know we've mentioned this before when we weren't recording, it is very important. And so maybe you can walk us through how you did that and some pitfalls that you've had along the way and why you think it is so important. And what does that even mean? I guess we should just start with what is a strong ML engineering culture?
Sure. No, at least in with the experiences that we've had. So when we first started hiring and we were scaling, and the number of projects that we were dealing with started to increase, we noticed that different individuals come from different backgrounds. So someone would have been let's say a software engineer in their prior experience. Someone would have been a data scientist. Someone could have been like a business analyst, and so they would come from diverse backgrounds. And at the end of the day, what we're trying to do is, we have a particular problem. We have, let's say, a 60-day goal or a 90-day goal. We know what, or at least the immediate North Star is, and everyone is trying to reach there. But that's when you would notice that, or at least what we did initially was that, oftentimes data scientists wouldn't really understand or comprehend what exactly moving to production means. Software engineers would have a very strong focus on code quality, optimization, and all of those things, which necessarily isn't something that, let's say, a data scientist or an analyst would have in mind. Analysts, for example, they would typically try to mine insights and gain observations as quickly as possible so that it speeds up decision making. But it's quite possible that a SQL query that they've written a week back, they're going to have to make a lot of changes a month down the line to get the same set of insights. So that typically slows down progress, and that's what when we realized the importance of at least trying to focus or invest in a strong engineering culture. And there are other, I would say, issues as well in terms of onboarding a new team member. What exactly do they learn? So it kind of started becoming like a big problem. So that was the trigger that we felt was a problem that we needed to solve. And we, of course, done a lot of experiments. Some of them have worked, some of them haven't. But I think one of the biggest learnings that we've had is for most things to begin with a system design document. Of course, the other thing also to put into perspective is that all of our team members, they all joined us after the pandemic or during the pandemic, so none of us have been able to see each other or meet each other. So that was also kind of a constraint that you're working with someone you haven't seen before or interacted with before. But yeah, I think this system design document is something that has been extremely helpful. So whether it's an exploration task or whether it's a new feature that needs to get released, we always begin with a system design, and the system design will have a few core components at the very least. So what is the exact business problem that you're trying to solve? Second is assume that the feature has already been built. What do you expect it to do? What exactly will you measure to make sure that the feature is working correctly, or whatever you've built is going to give you the right amount of input. So something which sets the business context into place, something where you try to look into the future and imagine that if a magical genie really built the feature for you, how exactly would you use it? And the second is, again, if it's a feature, then like a small architecture diagram and so on and so forth. And that eventually translates into multiple team members reviewing that, collaborating on those Google Docs, and then we finally coming to a conclusion. And apart from the fact that during brainstorming or during system design, this also speeds up PR reviews, because now a lot of team members have already invested their time in system design. They've already shared their inputs. So everyone is on a baseline page to begin with. So when there's a pull request, no one really has to spend 2 hours and 3 hours gathering the context from multiple Slack threads or a few emails and all of those things. It's already there in one place. And second is, whenever these discussions happen on system design documents, that's when you would see a lot of helpful discussions happening between data scientists and, let's say, ML engineers. So that's where you start to make, or they individually start to make a lot of trade-offs, understanding that, okay, if a software engineer or an ML engineer is thinking about this particular way of working that really makes his or her life easier down the future, then can I implement something similar, or can I at least adopt some of those workflows in my work, so that I can kind of I don't have to repeat those tasks. I think that's really been something that has helped us a lot. In terms of pitfalls, I would say while we at least focused on system design, we did not really focus a lot on how do we do the same thing for tests, or we did not focus on real-time monitoring. We did it a little later than we typically should have. So those are also, I think, things that we've tried to improve since then. But yeah, those would definitely be certain important pitfalls that we missed out on.
I want to get into some more stories, but let's just table that for just a moment, because you said something really interesting, and I know it is a hot topic in the community. It comes up quite a bit around data scientists not really understanding what production means. Were there certain things that you saw as patterns that a data scientist would fall into, or they wouldn't necessarily think everything through? And then when you had these system design documents and you had this back and forth with the engineers, they were able to think through. Can you think of any specific things that would come up and maybe we don't have to go through if you let us know?
Yes. So one of the relevant examples that I think that I can quickly remember is, for example, the use of helper functions. So of course, one of the use cases that we currently work on that involves personalized ranking of ads for users who are coming into a particular system. Now, we have a lot of microservices in there, and it's become a pretty big code base. But whenever, let's say, there's a new model or a new variant of the model that needs to get built, and this, I would say, sometime around maybe 6-7 months back. Typically, what some of our data scientists would do is, they would try to build that system or build that code from scratch. So that would mean writing a lot of customized functions as and when, while they were coding that entire thing, and just doing everything on a Jupyter notebook as soon as they can, and just to get to those specific model iterations and seeing how the model performs. And that, of course, also sometimes involves things like running for loops and all of those things, which of course are not always very optimal, especially when you're moving to production, and you cannot always afford to have such high compute or lengthy operations having in production. But then, while working with an ML engineer who had implemented a particular feature or something similar before, I think one of the very interesting discussions that followed was, instead of having probably 400, 500 lines of code, these are 5 helper functions that already exist in the code base. All you have to do is just read a Python file, and you already have that. So 50 to 75 lines of code gone. And then instead of having to write for loops, you can just simply do a vectorized implementation that's also available in one of the systems that we have running real time. So you don't have to run that again, or you don't have to run that for loop again. Just copy paste this code and use that. And that kind of and any of the later work that we would see from those data scientists, these practices were being adhered to more often. So they would see the value in it. They would see how that reduces their work. They would see how fast their operations would become, and eventually they everyone started to feel that it's really something that adds value. And the opposite is also true sometimes.
And were you doing code review? How did you find out about that? Like, how did the engineers give that feedback to the data scientists?
That was during the GitHub pull reviews, PR reviews.
I see. Perfect.
And yeah, the other example that I was going to give is just the other way around. So one of the other things that we also keep focusing on is experimentation. And you don't always have to build a model to run an experiment, especially if it's earlier, the earlier part of the earlier stages of the implementation. And this is another area where typically you would expect that a lot of data scientists would chip in, or they would create these models. But now what's happened is that some of our ML engineers, they because they understand the data, they understand the business better. They have a few quick hypotheses of their own, and that's enabled them to come up with a few ideas, and those are simple. The implementation is pretty simple. They already know the existing code base, so they've started running a few experiments here and there. So I think that's kind of helped them understand what's on the other side as well, of what typically data scientists do. Not the models exactly, but at least they can feel that any ideas or any hypotheses that they've had that's made it to production, and we've had certain learnings out of that.
Got it. Yeah, the data scientist software engineer interface, it's as Dimitrios mentioned, it's something that our community talks about a lot. It's something that is a common challenge in a lot of companies to define and figure out, how do you build these teams? How do you have different people use the skills that make them valuable to the company? And I think one of the comments that I most enjoyed recently in one of our recent podcasts was with Niall Murphy, who works at Azure, and he mentioned that what matters in a team's performance is not necessarily the composition from a skill standpoint. It's the composition from a behavior standpoint. It's what does the team do, right? Not what the team can do in theory.
Yes.
And so I think that from that standpoint, if you have data scientists that are taking into account these correct design patterns that you're talking about, then you're totally fine. Maybe you don't need to have an auxiliary team of software engineers to support them on the side as well. So with the progress of your product and with where Yugen is as a company, I'm curious, what are some of the industries or use cases that you think, with respect to MLOps right now are pretty nascent, but will be really, very important in the industry going forward? Is it something in healthcare or financial or, any of the other sort of industries that you're seeing that, there's some kind of repeatable use case that you guys would like to power?
Yeah. I think that varies a little bit by geography as well. For example, in India, we see a lot of retailers having who are currently at some of the early stages in their MLOps adoption, but that really is kind of picking up. It was a little bit decelerated by the pandemic and all those things, but I think that's really starting to pick up. I would say gaming, mobile advertising. Again, here in India, it's a pretty big field that's starting to, especially gaming, that is really starting to pick up the adoption. Some of the other cases, I think, yes, although we haven't worked on, let's say, healthcare or BFSI, any of those domains as part of Yugen, but I do think and this is what I've spoken to a few people, but we haven't worked on those sectors at all. Those are, I would say, at least the BFSI part would be a little ahead of the curve, at least compared to what we have here in India. And then media and interactive entertainment also, I would consider a little behind the curve in terms of MLOps adoption, or a little at a nascent stage.
That's fascinating to think about. And also just because India is such a huge place and there are so many different companies that are specific to India, and there's so many great startups that are coming out of India right now. It's interesting to see. I wanted to jump back a little bit. I know we're going to jump all over the place in this conversation, but you just touched on lightly the idea of having like the goals set out and knowing where you want to go 60 days, 90 days. But you also talked a little bit about this idea of minimum achievable goals and what exactly that means and how do you use it? What do you do with these? It's like an MVP, I would imagine, or yes. What is it?
Yeah, it's very similar to the concept of an MVP. The only thing is that, of course, because we are in the services industry, when we define, let's say, a 1 month or a 3 month goal, we typically get a buy-in from all different stakeholders. So it could be the product manager of a particular team, someone who's in marketing, someone from engineering, etc. So it's more of a stakeholder environment. So that's where we set these specific goals that maybe revenue is what's most important, and that's where what we need to prioritize over anything else. For another use case, it could just be the user return rates or maybe the user churn rates that we want to optimize for, and things of that nature. So that's something that we kind of prioritize for every month. And that eventually, of course, flows into our sprints. But the idea being that at any given point in time, you can find multiple ways to increase revenue. You can find multiple ways of solving that problem. And those multiple ways could then result in either spending some time working on multiple models or running multiple experiments, making small changes, etc. but what do you pick up, or which are the ones that you're placing your bets on? So that's kind of the idea, where we kind of identify those big bets as soon as we can, and make them short goals rather than 6-month goals or a year goal. We do keep that as part of the vision and the overall plan. But yeah, the idea is to kind of not spend a month or 2 months just building a model and kind of testing the offline accuracy and then sending it to production. If it shows promise in a few weeks, just move to production as soon as you can.
Yeah, that echoes so many things like that others have talked about on here. And I'm thinking about Laszlo when he came on here and talked about project management for ML. And he was saying how you really have to try and get something working as fast as you can to really know, is this something we need to spend more time on, and see if it's actually scratching that itch that we're trying to do. And then another guy, Oz, came on here and he talked about how when you're thinking about a POC with machine learning, you need to be thinking about production. You shouldn't just do something where you're training a model and you're doing it all on your laptop, figuring out, oh, is there value in this? And then you have to take it to production and do something that is totally new and different and difficult. And so you should start with the end in mind, really, I think is what it comes from. And so with that being said, dang, that was what I was I also was gonna mention that last week I had Yugen.ai on for the meetup, and he was talking about how he made like the first rule of machine learning is don't use machine learning. And that was after he interviewed a lot of people. He was saying how all of these ML engineers that he interviewed, and he asked different questions, he saw that there was this pattern that emerged. And the first pattern that he could pick out really clearly was that if you can avoid using machine learning, then do it, because it's just going to overcomplicate everything if you start to bring ML models into things.
Yeah, and I completely agree with that sentiment. And going back to the example that I've given some time back, which was the first time we had deployed a model, and this was eventually, of course, that the longer vision was to have a personalized ranking system that ranks different offers. But the first implementation that we did, and what was currently in place was a simple rule-based algorithm that one of our customers had adopted. And I remember the first model that I built was something that I built in 3 days. It was a simple linear regression model, nothing else. I mean, we just received access to the data. We just took a day to kind of understand, what it really is. And we, of course, did not aim to build an extremely great model. And of course, I think at that point in time, they probably had like a month or 2 months of data, and that too was a new product, so not a lot of users. So we just simply went with it, and that model went to production in I think around 2 weeks. And that's when we saw at least I think a 0.8 or a 1% increase in one of their KPIs. And I think that was the first step. Of course, since then we've come a long way in terms of adding user personalization, across different countries, and all of those things. That system has grown pretty complex. But yeah, I think that was our starting point as well. I mean, it may sound very simple in terms of the fact that it's not fancy at all, just building a small linear regression model. But yeah, that's what gave us at least a 1% jump.
And it's like do what works, right? There's no need to put on some insanely complicated thing that later you're just going to be pulling your hair out of your head because of it. So let me jump to another piece that I wanted to talk about, which were use cases that you have. And maybe you can talk about some of the different systems that you've set up and how you set them up, what some some of the challenges were, what they looked like technically, and then talk us through. I know you talk about the system design doc. We also are big fans, and David's not here right now, but he is like diehard system design review. He loves that right now. He's on a whole binge of it, and so for him, this one's for you, David.
Okay. Okay. So I think one of the long-standing problems that or ML systems that we've tried to build is the personalized ranking system that I mentioned some time back, and that's mostly in the context of mobile advertising for a different domain such as retail. I think we've done a significant amount of work on product recommendation and also replenishment. So replenishment being that, your warehouses will have limited stock, your retail stores are going to have, significant and varying levels of demand every day. So how do you kind of replenish, making sure that, each store gets what it typically wants? And then, and I think fraud detection is another problem that we've started working on. It's I would say in a preliminary stage with one of our customers, but I think those would be some of the top problems that we've been working on.
And can you talk to us about the practices that helped you build different ML systems? And I know you mentioned to me beforehand, like the monitoring of pipelines, the deployment infrastructure you used. Can you go into that with a little more depth?
Yeah, sure. So let me take the example of the personalization use case, because we have the greatest amount of history there. So, okay. Now, when the first deployment that we did for that particular use case was a simple linear regression model housed in AWS Lambda with a API gateway in front of it, and of course, you had a an engineering API calling that and getting those recommendations in real time. At that point, and the data warehouses, of course, were mostly in BigQuery, so we kind of linked any data sets or performances to Google Data Studio dashboards. So I think it was mostly like a 15 or 30-minute lag at which we could kind of measure, let's say, how different algos were performing, how different models were performing, what were the stats, and then all of those things. And we didn't have like a proper PR process for deployments. It was just a simple update of the deployment packages to Lambda. And this was when we were building models for just one country, limited number of users coming into that country, limited traffic. So I think that was the preliminary step. Over time, I think we added in a few other layers. So for example, the deployment process became a bit more mature. So we would typically do it via let's say a GitHub PR, and then via deploy board, and then canary, and that kind of a deployment. The model building part of it, or the data processing part of it, also gradually matured. So initially, because the scale of data wasn't really that much, we never really felt the use for multiple machines. So just a couple of EC2 instances to train our jobs would have sufficed at that point in time. But eventually, of course, we kind of moved to SageMaker once the scale of data really increased. We also, for a couple of use cases, had to move to Spark for some of our data processing jobs, especially for the fraud detection case that I mentioned. But yeah, that was typically the tech stack for the data processing part of it. For inference was when we at least started with the initial deployments. Like I mentioned, we weren't really doing a lot of user personalization. So at real time, we were not personalizing our rankings for different users. So which is why we never really needed a particular user's features. But when we moved to those models, that's when we had the need for at least online feature stores. So that part of it was something that was built in Redis, of course the AWS one there, and that kind of powered our the real-time inference engines. And I think some of the, what else am I missing? I think that's most probably what
And
comes to mind.
you had mentioned to me also like the scaling and going from, and I know this is every engineer out there is rolling their eyes because at all of the conferences, you always have somebody that will raise their hand at the end of a talk and say, but how does this scale? And so
That's so true. That's so true.
and it's so I mean it's an actual question. It's just I'm going to be that guy right now and ask you. So how was it? Because I know you talked about having, what was it, like 50,000 users, and now you're at 5 million per month.
Yeah.
Is it something like that? So maybe you can talk
somewhere
about
in that vicinity.
what were the growing pains in the scaling process.
Okay, so let me categorize that into two sets of pains. So one was one from a technical perspective. The second is in terms of our internal workings. So when we scaled, that typically meant that we had new countries, new sets of users coming in, and a lot of promotions running, which means a lot of new customer segments or demographics, they were coming in as well. So which meant for the current countries that we were operating in, there was a lot of data drift. We were not getting the same kinds of users. So that was a challenge from a model development standpoint. That I think we were able to solve because, or at least to a certain extent, we had prepared for it because prior to or subsequently after our initial set of deploys, we kind of at least set up some of those systems where you have the ability to spin up an EC2 machine and kind of an automated process to set up those environments and train your models and have those parallel jobs running. So something very, very basic, but at least you had the ability for or the room for multiple data scientists to be kind of working on those models. So that was one. Of course, deployments was also another challenge because you pretty much had at least 3 to 4 models getting deployed every 2 weeks, which was also a significant increase from what we had earlier. And of course, because we had that particular process of all models moving to production using GitHub PRs and deploy boards and all of that, which at least had some amount of monitoring present and some amount of accountability as well. So that lineage existed. From a technical standpoint, I would say most of the changes happened when we kind of transitioned from our initial, let's say, Lambda architecture to like an EC2 Flask-based system. And this, I think, was probably Jan or Feb this year when we were around the vicinity of maybe 500,000 users making around 1 million or so visits. And then that's when we understood or realized that, we need to kind of do a revamp of that particular architecture. So that's when, we had a major change in our system design. And I think we, of course, tests and stress tests and all of that. I think since then, we were able to get to that by probably the end of March. And I think since then, it's been working fine up until now.
That's awesome. Thanks so much for sharing in such detail some of the work that you've been doing. I think our listeners will really appreciate that. And to kind of close, we have a very, very favorite question of ours. It's Demetrius likes this one a lot, and we like to ask about war stories and sort of stories where things did not work out as intended, as they always do. You talked a little bit about the data drift, and that's one good example. I think earlier you mentioned about the data scientist software engineer interface. I'm curious, what's your best sort of war story that kind of taught you a lot about how MLOps actually happens?
Okay. I think the best one would be about a a silent error that existed in the system for, I think, at least a week and a half. This was probably, I think, October last year. We had deployed a particular model, and we of course had some preliminary metrics that we were seeing in our dashboards, and we were noticing that, the model's performance wasn't that great. So of course we started looking at the API, the logs, seeing what the responses were, and in a lot of cases we saw that it was as it was expected. And at that point in time, we of course had not prioritized unit tests or integration tests or any of that. And eventually what happened is that the API requests or the formats, everything seemed fine. And eventually what it turned out was that there was a bug in the code where instead of filling out a particular column with or imputing the nulls with a particular value, they were getting imputed by zeros. And the reason they were or most of them were nulls is because there was another bug in one of the SQL scripts that we had written. There was a change in the data warehouse, which we forgot to update. And therefore, pretty much everything was on track. It was just one join that was that was causing the problem. And, we never really caught it. I mean, in hindsight, it's a very simple problem that, we just have one column, all of them become zeros. It's a very important feature in the model, and the rankings get screwed up because, one of the most important features are zero for all offers. And we were not able to catch that for at least a week because we looked at a lot of different other things. We were also doing parallel deployments. We decided to kind of stop the work on that. But yeah, I think that's exactly the day or the week when we learned how much important tests are. I cannot emphasize that enough.
It was a week of realizing that something was wrong, but you couldn't figure it out. Was there time that you didn't realize it was wrong, but it was actually wrong?
So I would say the first 2 days is when we didn't think there was a huge problem, because what happens is that whenever we launch a new model, we kind of give it a particular traffic of around 20% or something of that, and what happens is the performances change, vary a lot by days. So on Mondays or Tuesdays, you may not really see a lot of new kind of offers coming in, but over the weekend, you see a lot of influx of great offers. So on a daily basis, there's a lot of variation. So the first day or two, we thought, okay, maybe the stats are down for this particular model because the production data is very different from the model, the data that the model has been trained on, and that was pretty much expected. So we thought we'll just wait for 3-4 days, a couple of more days. But then when it didn't work on the third day, and there was even a 25% fall, that's when we realized there's something that has to be off. I mean, it typically hasn't happened before. So I think that's when in another 3-4 days we got to the.
You had to do some digging. So
yes.
The other thing, I guess, that's really interesting to me is since that's happened, you've implemented tests. Do you also implement some kind of like data observability tools?
Yes. So I wouldn't say they are tools per se, not really mature systems the way at least we use it. But what we do is we kind of keep an eye on some of the most important metrics related to some of the features that are in production or some of the features that we will use in our model developments. So which could be something as basic as distributions over the last 3 months versus the last 7 days, 1 month, certain stats for weekdays versus weekends. So those are things that we kind of keep a pretty we track pretty regularly, not just directly on let's say the data that exists in the warehouse, but in some of the analytical data sets that exist downstream. So that kind of makes sure that there are certain integrity checks in place. If there's a distribution that's way off for a particular feature that we've built, then there's a possible, at least an indication that something might have gone wrong. It could really have happened in the last 2-3 days. But yeah, if it's consistent, then there's possibly something that we should definitely look into. but yeah, that's kind of helped. Since.
And was it all hands on deck trying to find that bug, or because you said you stopped feature, like you stopped trying to develop other things? Did you have to call everyone and say, we got to figure this out before we can do anything else?
Yeah, so that was I think at that point in time we hadn't like hired new people, so it was just me and my co-founder. But yeah, it was like all hands on deck at that point in time. We've had a couple of what we call like critical P0 issues a few months back as well. I think one of them happened a couple of weeks back. It wasn't as critical as the first one, but yeah, that was also like a all hands on deck kind of a scenario. So pretty much everyone working. But fortunately, that one, I think we got it in around 3.5 hours, and we were able to fix it in another 3. So this was a matter of a day. But yeah.
Thank you so much, Soumanta, for a amazing conversation. This was exactly what I think our listeners wanted. Deeply technical, but still fun and engaging, and with a lot of big picture observations about how MLOps works as well. And so thank you so much for taking the time to join us and share your perspective.
Yeah, I'm very happy to share both the positive as well as the negative experiences as long as it helps.
We always love hearing the negative, especially me. I love that because that's how you learn, right? Those
Yes.
memories they stay in your head. You don't remember all of the 90% of things that goes well, but like 100% of things that go wrong, you end up forming a strong mental picture around that.
Yes.
And then it stays in your head and you can tell people about it. And hopefully we don't have to go through that same thing because you told us. And also, I wanted to also mention before we wrap that you're in our Slack. So if anybody wants to talk to you after this, they can. You're also on LinkedIn and on Twitter, I think, too.
Yes.
So yeah, it was great talking to you, man. I really appreciate all of your insights.
Yeah, it was great speaking to you as well. Thank you very much.